Bom dia, pessoal. Good morning for everyone. Luísa, é um prazer poder estar aqui com você. It's a pleasure to be here with you. E para mim, assim, é uma honra, né, poder iniciar aqui o primeiro webinar, né, do Energy Hub em português e inglês, né? A gente vai fazer aqui meio uma mistura. It's an honor for me to be here and to do the first webinar in English of the Energy Hub. It's a really pleasure for us. Luísa, fica à vontade de se apresentar, Luísa. Feel free to present yourself for the audience. And I know that we're going to be a really great webinar about data-driven, that it's a really important subject. Vai ser um assunto muito legal, né? A orientação para dados, né? A gente poder ter esse assunto por aqui dentro do Energy Hub vai ser fantástico a gente poder falar um pouco sobre essa questão, né? Que hoje está muito em voga nas empresas, né? Como você utilizar os dados de forma inteligente, né? Luísa, fica à vontade aí para se apresentar.
Bom dia, gente. Então, como a Marcelo falou, meu nome é Luísa, trabalho aqui no Energy Hub com a frente startups, e a gente está trazendo hoje mais um assunto que é bastante relevante, né, para esse segmento. Então, data-driven e inovação tem tudo a ver, né? E hoje o ponto principal é justamente como usar esse dado, né, esses dados que as empresas produzem. Então, para começar aqui no webinar em inglês e português, eu vou ler para vocês a introdução, né, a descrição do webinar em inglês, para a gente começar a chamar nossos convidados. Então, hoje o nosso tema é Data-Driven Technologies, How to Use it to Improve Maintenance, Operations and Management. E a gente vai tratar do seguinte assunto. We've all heard the phrase data is the new oil, but do you know how to use the data your company produces? Without proper analysis that is capable of generating intelligence, data can become a lost asset. Let's discuss how data-driven technologies can be used today to optimize maintenance, operations and management. Então, a ideia é justamente essa, a gente gerar valor a partir dos dados que a gente produz nas nossas empresas. A gente pode começar a chamar nossos convidados, né, Mandarina?
Com certeza, Luísa. Vamos iniciar aqui, né, com o primeiro convidado. Nós vamos ter 3 convidados aqui especiais. We're going to be 3 special guests that we're going to receive in our webinar. We're going to be and have Henk Smith. And he we're going to introduce himself. And after that, we're going to be Felipe Murad from MindSIM and Marcelo Carvalho from Furnas. Vamos ter aí o Henk Smith, que vai falar um pouco sobre as ações, né? Uma pessoa extremamente experiente, né? Bastante experiente.
Ele trabalha com data-driven na Value Creation Network HCS. Ele vai falar um pouquinho da experiência dele, com, né, análise de dados, como isso é importante, né, para as empresas.
E com foco, né, basicamente, ali na empresa de petróleo, tem um grande background aí nessa área. O Murad, né, é uma pessoa que vem, né, atuando com a gente aqui na frente de startups, é uma startup residente do Hub, vem se especializando cada vez mais nessa área de ciência de dados também, né, e de busca, né, de conexão dos dados, né, e transformar esses dados de modo inteligente. E, obviamente, nem se fala aí, Marcelo Carvalho, uma pessoa que está aqui conosco, vai receber música do Fantástico, de estar conosco aqui, o time de Furnas aí, muito bacana, podendo participar aqui como gerente de transformação digital de Furnas, né? Então, é um prazer poder estar recebendo vocês aqui nesse processo. So, we're going to bring Henk Smith from our stage here now. Thank you very much, Henk, for to be here and stay with us and sharing a little bit your knowledge with us. Thank you very much.
Well, it will be a pleasure to give you some information about what I've been doing in the past. So we have been creating a lot of value for operating companies, and mostly it's the end user that have the biggest benefits. So that's what I would really like to introduce you to, how we can change the big data to useful data, which creates values.
Fantastic. It's really interesting. Luísa, we're going to bring the Henk presentation, I think. So we're going to be here, and we are seeing now. Henk, it's okay for you. If you want to start, feel free to start your presentation.
Okay, thank you very much for the introduction. It's and the honor to be participating in this seminar, because it's in the industry it's an enormous challenge to find the right data to make value of the problems which are encountering. So what we see is that the value what you can create with a maintenance group changes the maintenance group from a cost center to a profit center, and that is of course a different mindset. So what to do is to change the maintenance cost to a value, and that's what we'll try to evaluate. The presentation will start with a short introduction of machines and operating types and problems, then failure causes and statistics. We will increase availability by reducing risk. We will have the use of this information by maintenance planning, and finally conclusion. And this will be the start actually also for the next speakers, because they will use this kind of approach as well in their presentations. In principle, what you can see in the oil and gas industry, in the power industry, maintenance plays a high value of, actually is a high cost level in order to create value. But what you can do is when you define your risks in advance by a risk assessment, then you can see where you have to change your cost structure, because the costs are related to the risks. Oops, it goes a little fast. Yes. The availability is finally increasing of a process. So you can look into the cost of maintenance, but you can also look into the increase of availability, which brings the revenue for the company. When you can say, why do production critical machines actually fail? You have design errors by the manufacturer, you have installation errors by the installation company, you have operation and maintenance errors just by wrong things done. Then there might be subsystem errors which cause a cooling problem or a lubrication problem or other type of problem, process problems. Then there's sometimes instantaneous loads and variations and overloads which are not actually accepted for the machine. And finally, you have the main system components which can create fatigue and wear. So all these cause problems for the operation. And that means the end user will have high repair costs, complex logistics, and production losses. And of course, when the production losses are dominant, then you need to focus on those. But very often also the high repair costs are very important to judge. And that's depending a little bit on the type of industry what we address. The examples which I will use is coming from Impedance. Impedance is a French company which has started first on engines. Engines are a very difficult machine to monitor because the engines have a reciprocating process with combustion, and that is needing an advanced technology to find the problems in each of the cylinders. From all those maritime solutions, they went into the EDF in the energy for the nuclear power plants. They went into Veolia, which is for environmental measurements on the wind turbines. And then they went into trains, also important for transport, oil and gas, and automotive industry. So there's a wide variety of machines that can be addressed. But the first thing is always to start with a risk assessment. When you have a risk assessment for another type of industry, the sugarcane industry or whatever industry which is important in your local business, then of course you start with a risk assessment to find out what faults there are, and then you can adapt the system to the solution, to this solution. So what is the uniqueness of and the innovative approach of the impedance solution? They have lateral fault indices and torsional fault indices, and these are fault indicators. So in principle, what a system does, it samples extremely rapidly. It's 120 kilohertz per sensor. And then it has to convert the data into fault indices. And then you can store those fault indices, and you can do trend monitoring. But because it's a fault index which you have stored, you actually have a fault trend. And that fault trend can be used for creating a warning when there's a risk increase. So what you do, you define first from your risk assessment what fault indices you need to monitor. Then you start the monitoring, and when the risk is increasing, you get a warning. And this is applicable for engines, wind turbines, compressors, overhead cranes, gearbox-driven machines, and they all have one thing in common. There's a complex operation examples for varying loads, varying speeds, and intermittent operation. Just imagine that you have a machine which is only intermittently operating. It starts and stops and starts and stops and starts and stops. Or as a wind turbine with varying loads. Because all the symptoms which you have are typically also load derived. So if there's a symptom of a machine, then it's related to the load. And you need to compensate for that. And that's what a system does. And this is then an example of an engine. This is a 16-cylinder engine where you have all green and yellow fields, and even maybe there's some red fields. In total, one engine of 16 cylinders needs about 60, 70 parameters to be monitored. And depending again on the what risks you want to identify. So there are compression valves, there's ejection timing, injection condition, over-under power, bearings and moving parts, camshafts and pumps, stresses and pulses, twist angle, power loss, misfiring. So this is the result of the risk assessment. So if the compression valves are not functioning correctly, you know you have a serious problem on the machine. And then for each of the cylinders, this is identified what you need to do. So in principle, you have only two problems. It's on cylinder 5 and cylinder 11, and that's what need to be addressed. And this is the way you can throw away the majority of data. So first with the risk assessment, you cannot do everything, but you can do a lot. From this risk assessment, you define what sensors are needed and what data the display is needed, and then convert it into the fault symptoms. Then the fault symptoms that need to be stored is those which have actually an increase in level. So finally, the big data which you have on a machine is tremendously reduced. So the gigabytes of data is converted into kilobytes of data. And that's an enormous challenge to do it in a proper way, and that's what they have done in impedance. Of course, engine is not always present, and we need to check per market segment what is most important to check. And there's an example of the ORIDA database. ORIDA is a cooperation between European oil and gas industries, Shell, Total, BP, Exxon. I don't think it's Exxon in it. That's because it's not European. But Statoil is in it, so there's some 4 or 5 oil and gas companies. What they said is what you need to do, you need to have a clear description of all the failures that occur in a machine. So you start with the installation description, the equipment class, the subunits, the components, and then finally per component you define what failures have happened. And then those can be addressed by maintenance, and this maintenance event, it could be either a predictive maintenance event or a time-based maintenance event. So all this together is the logging sequence for all events in all the oil and gas industry for offshore and onshore. And that results in very interesting information, because it gives you the failure rate per machine and actually per fault. So when you have this logging in the correct way, you know exactly what faults have occurred. And to give you an impression, this is defined by 10 to the power of 6. And 10 to the power of 6 is equivalent to about 100 years. So you see, the boiler has about 4 faults per year. This compressor has about 2 faults per year. So this is the way you can interpret this data. And of course, you can do it also per week or per year or whatever, but this is the way they have started to do it. Because in principle, the machines are very reliable. But once a machine fails, you want to know how much time it takes to repair. So this is the active repair time. And it's also important to know how many people are involved in doing the repair, because that's a cost factor. So the downtime is causing interruption in the process, and this is cost of the people. And we don't describe here the cost of the components, because you also need to have the cost of components involved. So this is the way you can decide which things are most important for this plant. So in this case, it's the compressor, it's the boiler, it's the steam turbine. You have the water pump, because these two together are also 100. So one failure per year. And a failure per year is a very costly effect, especially with the present oil and gas prices. There was an example on the oil and gas industry. You can do the same for wind power. Wind park, there's a huge company which is called Fraunhofer Institute in Germany, which has a lot of experience in wind parks, and they have very good results. What you do here, you define the failure rate per machine and the downtime of the failures related to the failures. And the conclusion is there are minor failures and major failures, both with respect to the downtime and with respect to the failure rate. So the more failures you have with a conceptual high value, the more important it is to judge the risk. Just to give an impression of a short calculation, the annual downtime is depending on the major failures and the major failures. But like we said, we cannot do everything. So when you take the 0.3 days for downtime for minor failures with short downtime, then it leaves still 5.7 days per year for downtime for major failures. Then if you have a turbine of an example of a 3 megawatt, then it's 3 megawatt times 24 hours times 6 days is 432 megawatt hours loss. And that is equivalent to what is the market price of your energy. And this was based on a figure which I found in Brazil for 2019. It's 432 times 195. So this is just only production loss. So this is not this excluding the parts, the transport, and the work. And if you have to work on on a wind turbine, then you need to have a crane. You need to have the qualified people. You need to have the procedures all in place. And that is giving the large challenge for the maintenance. So what you need to do, you need to start with a risk assessment to find out what is most critical for your operation. With this information, you define what you can do. And if you do this, you limit yourself to not saying that I will do everything, because you cannot do everything. It's impossible. But if you address the major failures, like we see here, 25% of the total events represent 95% of the downtime. So if you do this, you will be a star in your company. Then you need to do a risk assessment, and in this case, for the wind turbine, you need to define the hub body, the pitch mechanisms, the pitch bearings, the rotor blades, the bolts, the blades, the aerodynamic brakes, the generator, the windings, the bearings, the brushes, the electric parts. So it's a lot of components which need to be addressed, because if some of these fail, then there will be a standstill. Unfortunately, when you do the analysis of many companies, then you see there's a lot of variation in the meantime between failure and the meantime to repair. So depending on where you have your installation, whether it's offshore or onshore, whether it's in a constantly moving area, a mountain area, difficult to reach, your meantime between failure and meantime to repair will be different. And therefore, it's necessary to do it always per wind park to find out what those values are. And this is an example of how you can do this. This is the failure rates per component. So for instance, this is a component, this is a gearbox. The failure rate of the sensors you find on the second lowest line. The electric control, the electrical system. So the top line represents the whole turbine, and it more or less starts looking like a bathtub curve, which is used very often in maintenance. But unfortunately, the bathtub curve depends on the individual components which fail, and therefore it's necessary to do the assessment per component. And that's the way impedance is doing this with the VBox. The VBox is the small rectangular box here, which only needs 4 sensors to make the major risk assessment. So what you need to know what are the torsional faults and what are the lateral faults. Therefore, there is a rotary sensor here on the generator. There's an accelerometer here on the output shaft of the gearbox. There's an input shaft accelerometer, and there's an accelerometer on the main bearing. So with these, you can completely describe the whole drivetrain with all their problems. And that's related to lubrication, cooling effects, efficiency errors, pitch and jaw errors, bearing wear, tooth wheel defects, and generator defects. And with those, you can define what needs to be done. Like I said, the VBox is doing all the data crunching. The VBox each channel is sampling 120 kilohertz with 24 bits on data resolution. So it's an enormous amount of data, and it converts the data into spectral data and capsular data. The envelope spectrum is a technology which is well applied in the mechanical monitoring, where you see the impedance, the impedance changes in the different frequency components. So if there are impulses, then there's apparently a high impulse which is affected by the bearing balls and the rollers. So here you see before lubrication is a high level, and here you see after a re-lubrication it's a low level. So the blue curve is after the lubrication, and the red curve is before the lubrication. Unfortunately, in this case, not both speeds have been the same. You can see there's a small change in speed, but it means that the components cannot individually be compared if you do not use the right technology. And that is what impedance has done. So what you could do when you see this bearing fault, it's still in the beginning phase. It can still roll continuously for a long period of time, but you need to re-lubricate the bearing. So that's why there's a statement for re-lubrication in the system. For other type of machinery, you look into different phenomena. For instance, unbalance, misalignment, starter behavior. Oops, it goes a little fast. You see here the run-up and the coast-down behavior of the machine, but it can tell you it's so difficult to judge all the phenomena itself by the specialist. You need to have a system that does this work for you. Then the good thing is all the data is still in the database available for verification by the specialist. So crucial is that we have the lateral fault indices embedded as a diagnostic measurement and converted into fault indices. And the same for the torsional fault indices. They're also embedded diagnostic measurements, which a lot of people do not understand, capstra and envelope to validate bearing and gear wheel faults. It's difficult to explain, and if you're interested in further explanation, we're outside this presentation, we'll do that. Then, of course, there's one issue. There's engineering intelligence and artificial intelligence, and everybody is talking about AI, artificial intelligence. But what we say, if you have the knowledge and the experience, then you can use your experience to define engineering intelligence. And there's so many technology used in the past, so this is still available. So that's the approach that impedance has used. You start with the engineering intelligence, and only afterwards you start with the artificial intelligence. Both approaches, they need one thing. Is diagnostic data quality. If you do not have the data quality, which means the repeatability and the fault sensitivity, both will fail. Both the engineering intelligence and the artificial intelligence will fail. So you need to load the system with the right information to get the results. In this case, it's very simple because you have your faults defined. So you get a warning specification, you get your fault trends and your fault forecasting. And here you need to start with machine learning, a large number of machines, but you always need to include machines which have a fault, because otherwise it will never learn. You have a large quantity of machines, fault statistics you get, then you need to interpret the changes in the models, and then you can make a fault diagnosis. So this is a more complex way to identify faults than this way. This is the easiest way, and it gives the shortest results. So when you do all the planning, then you need to have the parts, the people, the procedures, and the planning. So the 4 Ps of the meantime to repair. So you need to have the availability of the replacement parts, the knowledge about the replacement procedures, the availability of the qualified maintenance personnel, and the planning to meet the maintenance window. Therefore, early fault warning is essential. If you don't get an early fault warning, everything fails, because you need to have the time to plan your maintenance. So conceptually, it's all about this. You define with a basic business risk matrix, a FMAKE analysis, failure mode, effect, and criticality analysis. From this, you define what you want to know, which sensors, which data, and that's what we call the condition monitoring. From this, you will get the fault and risk development, warning, and a fault forecast. This is then used for correction and consolidation of the data, and that gives the business value where you can base your results to. So when you know exactly what the risks were, then you can quantify when you return the investment which you have paid. So this is what we emphasize. This strategy is actually defining what you need to do. If this is of interest for you, we are interested in seeing cooperation with you, where we say, okay, what are the next steps? Then it's a principal commitment for cooperation, the responsibilities, who is doing what, the risk assessment, the value approach, the warranties, the procedures, the installation, the support, and documentation. That need to be in a conceptual proof of concept defined. And if you do that, then it will definitely be successful. So I'd like to thank you for your interest, and I would like to help you with the successes in your value creation. Thank you for your time.
Excellent presentation, Henk. It was really interesting for me to see and to know a little bit about prediction and maintenance in this sense. And for me, it's really interesting when we talked about like put together. Normally, we talk about technology and disruption technology, and we are seeing AI as the savior of everything. But you really think that it's very important to combine engineering and engineering intelligence and AI intelligence. So it's really interesting that, because sometimes all the engineering and the engineers thinking that, okay, AI, we're going to change my place in the work, and we're going to be redundant in the sense. So for me, it's really interesting. It's like to create value, we need to combine the intelligence, even the guys in the field, like seeing that and analyzing the data, and of course the machinery trying to collect the data and organize the data for us to bring and to manage that and to take a decisions.
What I would like to comment is it's very important to define what are the risks, because when you know your risks, and so you need to have a dialogue with the maintenance group, because the maintenance group knows this. They have the experience, they know this. And the bad thing is with AI is that everybody's talking about intelligence. But if you don't put the right data into the intelligence, it will never come to a conclusion.
Perfect.
If you work with machinery which have no failures, then how can the system learn about failures? So machine learning is depending on what you put into the system. And the good thing is the maintenance group is so intelligent. They have a lot of good things. They have a lot of knowledge. The only thing is they're bad in their sales process. They are not selling it correctly internally in the company. They could do a major job. I had a discussion with Petrobras, which was very interesting. And I just talked to the maintenance group and I said, well, you want to have this kind of technology? I said, yes, that's very important. Then they said, yeah, but we just got a question to reduce our budget. I said, which idiots decided to reduce your budget? Because you're a profit center. He said, yeah, we're not a profit center, we're a cost center. I said, no, you're a profit center, but you need to sell it in this way. Then we went to the manager who had said to reduce the budget. And in 2 days, we got a commitment that the money would be approved. And they just have to say which parts of the plans they want to do. And that was the onset of our business in Brazil. So always maintenance people form a major part in the operation.
It's really interesting in this part because normally the company see as a cost center and not a profitable center, and it's really difficult for the standard companies to calculate all of the losses, and that's why normally we see the maintenance as a center of cost and not a profit a center. So this is really interesting change of perspective and a way to empowering in the sense all the guys there and the maintenance people. So this is really interesting. Luisa, we have like 2 questions here from Thiago Peixoto. If you could read for us, it's really interesting for Henk.
Okay, so Thiago asks, is expected in short term to have some protocol, API, or standard to make easier to implement these AI algorithms?
Is a question for me?
Yeah.
Yeah. It says, how can we use that? How close we're having to use like disruptive technology, for example, to do the maintenance and the predictive maintenance.
Well, the interesting part is that we don't need their standards. We just need to have experience. And also the maintenance group has a lot of experience. So you need to have a dialogue with the people. What has gone wrong and why does it go wrong? And if you know that, then you can define what you have to measure. So it's basically the risk assessment. But what I see in a lot of maintenance groups is that they specify too many problems which have a low added value. So you need to focus on those things which have a high added value. Like I just explained in the wind energy, you can look into the cost of the lost production, which is something like $80,000 a year, which is of course not good. But if you say what is the cost of the crane, what's the cost of the specialized people, what's the cost of the transport, what's the cost of the gearbox, if you have to replace the gearbox, then you make the full picture. So if you can extend the lifetime of the gearbox, then of course you make money for the company. And of course, at a certain moment, you need to replace it. But the planning is most important in the whole story, to do the planning at the right moment when it's really necessary. And with time-based maintenance, every company has done a traditional approach that let's be sure that we run the machine in a way that it's safe, and therefore we replace it too early.
No, that's great. Okay, so Thiago sent another question. He asked, would it be feasible to trade training algorithms for other companies in the utility sector?
You think that it's possible to bring the some knowledge from, for example, one sector to another? That's really interesting because we have, for example, in energy, we have oil and gas, for example, and electric sector. So and sometimes it's really different when we talk about the kinds of equipments that they use and things like that.
Precisely.
So it's possible to share this kind of knowledge in the sense, for example, we have a compressor or, for example, a pump.
A hydro turbine.
Yeah, it's, for example, hydro turbine. It's possible like to bring that kind of knowledge, for example, from one sector that uses that is a heavy user of this kind of machinery, and it's accustomed to use these data to, for example, other sectors. You see that in your knowledge?
Yeah, I would say no, it's not possible, because the components which fail are different. So, of course, if you have similar components in similar machines, then, of course, you can share it. Because a rolling element bearing will fail in the same way as a journal bearing. And a gearbox will fail in the same way. But the question is, do you have a gearbox? In wind energy, you see a change that they want to increase the number of machines without a gearbox, because the gearbox is one of the major contributors to failures. So you need to make a risk assessment, and based on the risk assessment, you define which components are there, and from that you can define what you can use as algorithms and what cannot be used. Unfortunately, it's not so simple.
Yeah, it's okay. I think, Luisa, we're going to thank you very much for Henk. To come back in a few minutes after the presentation of Murad and Marcelo, for us like to discuss a little bit more about this really fantastic subject. Thank you very much for your presentation. It will be like a great start for us in our webinar.
Okay, success.
Okay, thank you very much. And Luisa, vamos chamar aqui o Murad, né? We're going to call Murad aqui for your webinar. Murad, seja bem-vindo aí, muito bom. Welcome.
Hi everyone, good morning. Thank you very much for your invite, and it's also always a pleasure here to be representing MindSIM in this discussion here. Henk already said a lot of things about maintenance, and I think that my presentation here will also complement what he's saying in regard of risk assessments and a lot of other things related to costs and how the maintenance guys sell itself. That was brilliant from the Henk's perspective. And I think that will be a nice opportunity for our audience here to actually understand a lot more of the concepts behind planning and behind maintenance itself. So it's always a pleasure, and thank you, Energy Hub, for the invitation.
Nós é que agradecemos. Thank you very much for your time here, and we are going to bring your presentation for you to start. You can put in the screen. Yeah, we're seeing now. It's only to feel free to start. Yeah, it's okay.
Perfect.
Feel free to restart. We're going to be in the backstage, and good luck.
Very well. Well, good morning, everyone, and thank you, everyone, for the time for seeing me presenting about MindSIM itself and about what we do here. I'm one of the co-founders of MindSIM, and actually I'm the CEO. And well, MindSIM is a tech company related to the Industry 4.0. Industry 4.0. We know that from this sector, we have a lot of pillars regarding Industry 4.0. We have mobile devices, IoT platforms, authentication and fraud detection, 3D printing, and many other pillars. But we are focused especially in the big data analysis and advanced algorithms like simulation and AI and big data and AI algorithms. And this is interesting because here is how we collect, we extract information from your data, and that's the pillar that we are focusing. And well, since the beginning, since our start here, the creation of MindSIM, we'll be doing a lot of stuff with other companies, big companies like, for example, Shell, regarding their acceleration program, Subsea 7 in the See the Future program, which became later on our first clients here, and the first one to adopt our maintenance technology that we will be discussing here. And recently we won the Petrobras Conexões para Inovação. It was a program from Petrobras and Sebrae, and we will be doing a lot of data analysis with them regarding the digital twin, which is another technology that will be just mentioned here in this brief presentation. We now have a lot of partners here. We have Media Lab, which is a lab from UF, who will be cooperating with us in this Petrobras Conexões para Inovação. We have the impedance group, which is currently being represented here by Henk, and they are really experts in the predictive maintenance and how to extract value from vibrational data. And we also have NVIDIA supporting us regarding the technology. And we are also in some other hubs. We are in the Fábrica de Startups hub and the Energy hub, which is the one that the current one that we are talking here, and who is promoting all this webinar and all these discussions here. So the main objective of MindSIM is actually to make the operation of our user smart, and by that we define a smart operation by the one that has systems that automatically instantaneously respond to these questions: what is happening, why is happening, what will happen, and what should we do. And for that, we have a lot of methods and technologies to answer that. We have dashboards, we have statistical analysis, we have prediction, and this is where the machine learning takes part. And we have optimization algorithms to enhance or to identify bottlenecks and other major effects that affects the operation. And based on this methodology, we created two projects here, which is the digital twin, in which we try to clone, we try to derive a digital copy based on the data of the user, especially if it is in real time. And you can use this digital copy to understand the system, to train the personnel, or even to identify the bottlenecks of your operational system. And that's the major beauty of it. You can use the data to actually identify what to improve in your operational scenario. And now we have the MindSIM maintenance tool, which is the one we'll be talking here, and is a software to actually improve your maintenance management by enhancing your planning and refining your planning capabilities with data and AI-driven software, naturally. Both of them are AI-driven softwares. So let's talk about planning, right? Henk told us a lot of things about predictive maintenance, especially, and also about the importance of the risk assessments and the importance of planning here. One of his 4 P's is planning, right? But what happened is, just to give a brief of introduction, what happened is, due to the competitiveness of the industries, the industries needed to reduce their costs, and by that they needed to try to reduce the available resources that they have. But the number of tasks and the number of jobs that they needed to do only got more complex or only increased it. So what happened that you needed to do more with little, and because of that, a lot of companies develop some maintenance plans or maintenance model plans that try to answer this question, the risk assessment question, which is, what are the jobs, what are the components that are more critical and I need to do now? So who tasks should be prioritized, which ones should be postponed, and which ones that were already postponed and we should do now. So that's the main question here. And to do that, you usually do a risk assessment of the components to identify the most critical one. But when we are doing planning, we usually are interested in two more questions, right? The what we do, the when we do it, and who will be doing it. And for the risk assessment, we are trying to understand the first question, which is what are the major components and what are the tasks that we should do now to add value to the clients. Because as Henk said, we don't have the resources to do everything, so we need to prioritize the most critical ones. And to do that, what this model, the prioritization model that the companies are usually doing, at least the companies here in Brazil, is that they receive a lot of information from the tasks or the components, and this information passes through a flow chart or something like that, and they are classified into groups based on their priority. So group 1, group 2, group 3, and these groups generally they are related to the nature of the consequence of the if the task generates a fail. So for example, if the task is a critical to safety or critical to operation or critical to environment or even a critical to finance tasks. And obviously the component is also classified in another kind of group. If you have a redundancy, if you have if the component is really critical, that can compromise the whole operation. So all these things, all these components information are classified into groups. So we can, this is normally what we do now. But this approach actually has some problems here. And for example, we have imprecise classification of components and tasks. For example, if I pick a component for the two different components or two different tasks from the same group, we don't know exactly what task should be done first and what task should be done next. For that, because of that, you leave this information to a subjective evaluation of the planner, of a person who is analyzing all this data, all these tasks, and he is based on his experience. He is prioritizing these tasks, and naturally, this has the problem that, well, everything has been done manually. So the guy actually starts looking at these tasks and analyze these tasks manually. And because of that, we also lose a lot of statistical effects related to the history, the history data, and that could be used to give a lot of more refinement of in the planning. And because of that, one of the problems that most companies face is this subjective evaluation. Every time the planning also depends on the experience of the person who is planning it. And it can be good, but it also can be bad, especially if you replace this person. So these are so what I wanted to show you is this categorical approach here. The problems that is doing this has a reason from doing this as a categorical approach. So what we saw in some companies is that the percentage of tasks are usually left in the same group. For example, in the represented here in the first case by the blue bar, and on the second case, on the second example, by the blue and orange bars. And in the first example, we have 90% of the task in the same group. And by doing that, we are not prioritizing anything because we don't know exactly from this group what to do. In the second case, we have a minor problem because we have 50-50. But from inside these groups, we don't know which task should be done first and which task should be done next. And to do that, to correct this, we came with another approach here, which is basically doing statistical analysis and doing an AI approach, AI-driven approach, in which we collect data from all different database. For example, operational conditionals, maintenance history data, corrective maintenance and fault events, resource availability. All this data is cross-checked by a software, and the software, by analyzing the planning decisions of the planner, he's come to give a score for each one of the components or each one of the tasks. And usually this score varies from 0 to 10. 10 are the most critical components, and 0 are the components that are not so critical, for example, are the least critical. And all this is done by statistical analysis of the data, which is almost like done instantaneously. So the software picks this data, analyzes, and puts it on a score. And this score is this number. So notice here that now we have all the components organized per this. We don't have a category. We have a number that is a attribute to each component here. And of course, by doing that, we can have this risk assessment done on the level of the tasks. So what we've done, we created a software that collects the data from the maintenance history, that collects the data, that do this risk assessment based on all this maintenance history, the statistical analysis. And based on this statistical analysis, we do a machine learning process to try to reverse engineer the decisions made by the planner. And by doing that, we have a model that is able to not only to identify the most critical tasks, but also to try to forecast and predict when we should plan certain activity. So by that, we reverse engineer all the criteria regarding the decisions of the planner, and now we have an objective planning instead of subjective planning. All this prioritization of the maintenance tasks are left in a list, in a huge list with all the prioritization. This is a screenshot of an actually screenshot of our software. So here we have all these tasks, all this score of the tasks here from 0 to 10 given by our AI algorithm. So the user now, instead of looking to all of his 242 tasks, he can look only at the first 20 ones, which saves a lot of time and actually brings a lot of more consistency to the planning. Also, we have here on the right side, we can see this risk assessment done by components of the equipment tree. So for each one of the components, we also attribute to a score that says, okay, based on the feedback from the planning crew or the planning of the maintenance planning, we know that these are the most important jobs, that the most important equipment that needs to be prioritized first. So it's actually an interesting idea, because to these equipments, especially if they are rotational equipment, we can apply predictive maintenance, which is a more costly solution than the other planning methods, the predictive and the prescriptive and the corrective maintenance. And we also have this score attributed by the departments of the maintenance. So we can now see to which department we should focus our energy here. Furthermore, we have the operational scenario. We know that the planning of the task is also affected a lot by the operational scenario. If we have a machine that is operating, we can't actually stop the machine to do the maintenance. So all this maintenance, all the time that we need to do maintenance, it needs to have the availability of the machine itself. So by operating this scenario here, on the right upper corner, we can have we can show you, okay, based on our model that we produced, we show that the most critical components for your exact moment are this one, because these machines are not operating yet, so you can intervene and make an intervention in these machines. And not for least, but we have also the distinguish between the normal jobs that we usually have and the backlog of the jobs, which are usually the jobs that we don't pay attention at the initial moments. But if you don't pay attention for a long time, they actually become critical and may affect the whole operation, depending on the case. And that's what we from MindSIM we're doing with a lot of major companies, especially on the offshore industry and the steel industry. And this is how we can increase the value of the planning and increase the refinement of the planning. We also can integrate the software with predictive maintenance and also any kind of AI-driven or data-driven technology. Especially in particular for the predictive maintenance, the software can make this risk assessment, identify the most critical equipment, right? And to that equipment, you apply the predictive maintenance, because we already know that for wind power plant, for example, we don't need to apply predictive maintenance to all your turbines, only the most critical ones. So we can use the software to identify these critical ones, and then you apply the predictive maintenance only to those equipment, saving a lot of costs to implement in all the equipment itself. And another form of integration is right the opposite. We can have these results from the predictive maintenance, right? The conditional monitoring and the health of the equipment into our and the fault forecast also into our software to improve the refinement of the planning. So now we can have data traveling from one place to the other instantaneously, and this can affect the planning in real time, or at least in a period of time. Depends on how we want to update the system. And this is also a novel concept that is not done anywhere in the industry at the moment. We don't have predictive maintenance integrated with planning maintenance using AI-driven software. So this is a novel concept that we bring here to the market. And so just to conclude my presentation here, I want to show you why we should actually use this AI-driven technology in the maintenance plan. Well, first, we have a lot of more refinement in the planning, and by that we have some statistical analysis and variables that are usually neglected during the planning, because in the heat of the operation you don't have the time to look at the history, so you only see the current state of the operation, not the history. And this leads to more assertive and robust planning, and by that we can reduce maintenance costs while enhancing operational security. And for that, we have some cases here regarding how we can do that, practical cases here especially on the offshore industry. But we'll leave that for another presentation, a more specific presentation, if you want to do it with us later. Not only that, but we can, by using this, we have now objective planning instead of subjective planning. And this brings a lot of value, because doing this objectively, we can highly escalate the decisions to multiple operational plants. So we can have a plant, a vessel, different vessels learning the same thing, different vessels using the same methodology to plan their maintenance tests. And when we change this methodology from one side, we're also changing the other. So as it is an AI-driven solution, it is highly scalable. Not only that, but we have a more consistency in the maintenance planning, because now we have a machine that has this objective planning here, and it not depends on the human experience, or depends less in the human experience. Also, we can use this software to identify bottlenecks, because the software represents the criteria that the planner has. So we can use the software to criticize the planning, showing that, these variables here should not be considered should not have much importance as the other ones. So we can use this to optimize the maintenance plan. We can have this integration with a lot of other data-driven technologies, like I said, with the predictive maintenance. And now we have also some new KPIs available at your disposal to effectively measure and to effectively improve the planning of your tasks. So this is from me here. I wanted to thank you a lot regarding for the opportunity to present what we will be doing. Here are my contact information. If you want, you can also access the MindSIM site and have go to our LinkedIn and or contact me through LinkedIn if you want any questions, or by mail also. Thank you very much, guys.
Thank you, Murad. It's what a presentation. It's really interesting to see MindSIM evolution of your technology and your team. It's like bringing to the market, to the energy market. And for me, it was really interesting to see integration, that it's really important in your presentation. When you connect technology, people, and process, it's the base to do this kind of technology and trying to bring value for the clients. So it's really interesting. And I didn't see yet the concept of doing backwards and doing re-engineering, for example. And it's really interesting, this kind of concept. Congratulations of that, because sometimes it's very interesting to bring the knowledge from the data. So that's I think it's a differentiation that you have in your approach. We have some information here, some questions that we have, but I think it's better to bring Marcelo to talk a little bit, and after that we are going to the knowledge and talk a little bit with all of the speakers. Okay.
Can I just answer the questions from Thiago? I saw that it's a pretty interesting. They were pretty interesting, but I can answer.
Yeah.
Later.
If you
that's the comment from Thiago.
Yeah. No, the questions. The previous question.
Yeah.
Sure.
Thiago conhece, né, o Murad, né? Thiago knows Murad, and when we know in this level, sometimes it's like this. It's an internal joke. It's é muito engraçado e é muito bom, né, ver o Thiago, né, uma pessoa importante aí do ecossistema também de inovação de formas, dando essa força aqui para o pessoal e vendo, né, a evolução aí da galera. Ele citou outras startups aqui do Rio. Thiago talked and bring some others. Guys,
quero agradecer o Thiago aí pela ajuda, principalmente.
Você quer comentar as perguntas anteriores do Thiago, Murad?
Yeah. So actually what he said is about an API here. What we are seeing from some industry doing this is that they are trying to develop an internal, not this one, the API one. They are trying to develop internally an API, a major API that the startups or other companies uses the API to collect the data from their database. So there is something that the companies have been doing this in this regard. And the other question that he posted, would it be feasible to trade training algorithms from companies to utility sector? I don't know about the utility sector, but when we are talking about especially machine learning, we have some kind of methodology that is called transfer learning. That we can use the data from one side to train our algorithm, and with these algorithms, we actually can train the other and another algorithm. So we can have something like that in this regard. It's called transfer learning. It's a type of learning in the. It's done basically on the academic levels, but you can also have this.
Perfect, Murad. Thank you. We're going to bring in a few minutes again here to talk with all of the speakers. And thank you very much for your presentation. And see you soon.
See you soon, Mandarino and Luisa.
Legal, obrigado, Murad. Vamos trazer agora aqui, né, Luisa, aqui ao palco aqui, o Marcelo de Carvalho. Marcelo, muito bom aqui tê-lo aqui, né, depois aí desse caminho aqui que a gente está seguindo, né, começando com o Henk, depois seguindo com o Murad, ele tentando, né, tangibilizar um pouquinho aqui para a gente essa visão aí dos softwares, se trazer, né, alguns cases aí de aplicação de data-driven em Furnas vai ser para a gente muito bacana aqui, conhecer, né, um pouco dessa história, né, e desse caminho aí, dessa jornada, né, vamos dizer assim, que Furnas vem construindo aí com essa visão do data-driven, né, e você, né, basicamente aí liderando também esse time, a Ana, né, como uma das grandes entusiastas aí de Furnas, né, em relação ao data-driven, Aninha, muito bom aí ter, né, essa possibilidade de ter esse compartilhamento de vocês aqui com a gente.
Obrigado, Mandarino, obrigado aí pelas palavras e também pelo convite. Agradeço aí a oportunidade. A ideia é realmente falar aqui sobre algumas iniciativas, não só de manutenção, quer dizer, especificamente de manutenção preditiva, né, que é o tema aqui do nosso assunto, mas falar um pouquinho como é que a gente conseguiu nos organizar para chegar até lá, né, para a gente efetivamente poder tocar iniciativas desse tipo, né.
Perfeito, Marcelo. A gente vai sair agora aqui, já estamos com a tua apresentação aqui no ponto, tá? Fica super à vontade aí para iniciar. For all that we're seeing us now or after, we're going to have this part in Portuguese, but all of the lecture is in English, so it will be good to be with Marcelo after that to answer questions that we have. Marcelo, fica à vontade aí, obrigado.
Obrigado aí, pessoal. Bom, bom dia a todos que nos assistem. A ideia hoje é a gente falar um pouco sobre as iniciativas de manutenção preditiva que a gente vem tocando aqui em Furnas, né? Temos uma agenda aqui. Primeiramente, vou falar um pouquinho sobre Furnas, né? Não sei se todos conhecem, né, a empresa. Depois, falar um pouquinho sobre as companhias data-driven, né, e como esse tema vem tomando uma importância muito grande, né, ao longo dos últimos anos. Vou falar um pouco sobre o nosso time de transformação digital. Nós estamos em Furnas. E finalizar com 2 cases que estão em andamento em Furnas relacionados à manutenção preditiva, que é o tema aqui do nosso evento. Então, falando um pouquinho sobre Furnas, né? Furnas é uma subsidiária do Grupo Eletrobras, está presente em, na verdade, 15 estados e mais o Distrito Federal, aqui no Brasil. Opera no setor de geração, transmissão e comercialização de energia elétrica. E 40% da energia do Brasil passa pelo sistema de Furnas, né? Furnas realmente tem um porte muito grande e isso dá até para constatar a partir de um vídeo institucional que eu vou passar aqui rapidamente para vocês conhecerem um pouquinho mais da realidade da empresa. Bom, pessoal, são números que realmente impressionam, né? Assim, o porte da companhia realmente e a sua importância no setor elétrico nacional. Falando um pouquinho aí sobre as empresas, né, data-driven, a gente sabe, né, que a transformação digital ela tem levado as companhias, né, a se tornar data-driven, ou seja, passar a analisar e interpretar os seus dados, né? Principalmente ligado às suas atividades fim, né? Para um melhor posicionamento estratégico nos seus mercados, né? A gente sabe o quanto que a competitividade, né, vem crescendo, né? A competitividade entre as empresas vem crescendo e o setor elétrico é um desses setores aí que mais mostra o quanto que esse setor é competitivo, né? E o quanto que a tecnologia pode fazer diferença nesse caso. E aí, nesse cenário, né, os profissionais, eles buscam por uma requalificação, né? E as empresas buscam desenvolver, né, novas habilidades no seu corpo técnico, né? E um conhecimento mais estratégico sobre esse assunto, né? Na verdade, assim, quando a gente fala de data-driven, na verdade, quando a gente fala de transformação digital, a gente aquela antiga ideia, né, da TI como a grande área responsável, né, pela tecnologia dentro da companhia, ela muda no sentido em que a empresa tem que passar a ser digital, né, e isso tem uma série de questões aí relacionadas à própria cultura, né, a cultura da empresa, né, a destreza digital do seu corpo funcional. E isso tudo coloca a TI com outro papel, né? E principalmente o time de transformação digital, um outro papel dentro da companhia que eu vou falar um pouquinho mais à frente. E para a evolução desse conhecimento é necessário um esforço constante, espírito inovador, capacidade analítica, e isso é algo que precisa ser desenvolvido, né? Só para assim, chamar um pouco a atenção essa questão dos dados, né? A gente fala que o dado é um novo petróleo, né? Mas tem uma questão aí, o petróleo é um recurso finito, né? E os dados, ao que parece, estão seguindo para uma infinitude, né? Para um caminho de infinitude, né? Eu trouxe uns números aqui. Em 2017, né, cerca de 90% dos dados armazenados na web tinham sido gerados nos últimos 2 anos, quer dizer, 90%, né, em 2 anos. E em 2020, a internet já alcançava 59% da população mundial. Quer dizer, a produção de dados, ela é algo que realmente tende ao infinito, né? Não é um recurso finito, né, como o petróleo. E a gente até então, né, as empresas, né, elas vêm de uma era dos sistemas de informação que automatizavam, né, e ainda automatizam os processos de negócio, gerando bases de dados de diferentes domínios dentro das empresas, né? E a transformação digital ela chega justamente para fazer um uso inteligente desses inúmeros dados, né? Tanto internos à companhia quanto externos, né? E nesse aspecto, pensar o dado como um ativo é fundamental. Então, como eu falei, assim, a mudança, né, o aspecto cultural, ele é muito importante nesse processo, né? No processo de transformação digital, especificamente quando a gente fala de empresas data-driven. Tem alguns outros números aqui bastante significativos, né? Assim, projetando para um futuro muito próximo, né? Em 2024, 30% das organizações vão investir em governança de dados e plataformas analíticas, né, que são temas diretamente relacionados a uma cultura data-driven, né, e aumentando, né, o seu impacto de negócio, né, gerando insights, enfim. Em 2025, 80% das iniciativas de analytics e governança de dados vão focar em entregas, em resultados de negócio, né, e vão se tornar críticos, né, para definir as capacidades do negócio. Também em 2025, 80% das organizações vão escalar seus negócios, vão falhar em escalar seus negócios digitais porque eles não têm uma visão moderna ligada à governança de dados e analytics, né? Nós já percebemos a importância tanto da governança de dados quanto de plataformas analíticas em Furnas. A gente já vem trabalhando com isso até para estruturar esse tema de maneira adequada. E governança de dados é algo que assim, é fundamental para dar conta de processos ligados à manipulação desses dados dentro da companhia, né, segregação de acesso, perfis, tem uma série de definições que precisam realmente, assim, não adianta você olhar para um bando de dados e achar que você vai conseguir extrair inteligência daquilo sem processos, sem governança, sem controle de acesso. Então, isso é fundamental, e a governança de dados é que traz isso para a companhia. Além disso, obviamente, existe todo um aparato tecnológico, as plataformas de analytics, elas são fundamentais para viabilizar essa transformação de dados em informação e em conhecimento para a companhia. E aí, assim, como é que, dado esse cenário, como é que a gente se organiza, como é que uma empresa pode se organizar para dar conta de tamanho desafio, né? E aí, falando especificamente de Furnas, né, a gente, em 2020, né, a gente foi criado, né, foi formalmente criado o Departamento de Transformação Digital, que integra a Superintendência de Tecnologia da Informação da companhia, junto com o Departamento de Planejamento e Governança TI e o Departamento de Arquitetura e Segurança de TI, com a missão de impulsionar as áreas de negócio com soluções de TI inovadoras, né? Esse é o nosso propósito, né? Nós nascemos com esse propósito e eu sempre digo que a gente já nasceu disruptivo, porque o nosso departamento ele foi criado em fevereiro de 2020, em março estávamos na pandemia, tendo que nos readaptar, nos reorganizar, todos trabalhando de casa, né, vivendo esse momento super distópico que a gente viveu e agora está saindo dele, né? E a gente já começou disruptivo, porque a gente teve que efetivamente nos organizar, nos estruturar num momento completamente diferente, né, do que até então era a nossa vida, né? Era o nosso normal. Então, a gente, um dos trabalhos que nós fizemos, né, e assim, até como estruturação do nosso departamento, né, nós definimos qual seria a estratégia da superintendência como um todo e do departamento em particular, e nós chegamos a um entendimento de que a gente precisava atuar nos 3 horizontes de inovação preconizados pela McKinsey, né? Não sei se todos conhecem, mas a McKinsey define 3 horizontes de inovação, horizontes 1, 2 e 3, que são horizontes de impacto da inovação, né? Então, assim, a inovação ela pode surgir na empresa através de uma melhoria de um processo já existente, desde a melhoria de um processo já existente até a criação de um novo negócio, com o uso de uma tecnologia disruptiva, né? E é importante que a transformação digital ela consiga abarcar iniciativas desses 3 horizontes, porque é óbvio que a gente não vai surgir a cada momento uma solução disruptiva que gere um novo negócio para a companhia, que gere uma receita de milhões ou bilhões de reais. Isso, assim, um Uber, um Airbnb, isso não nasce todo dia, né? Assim, dando exemplos bem extremos, né? Então, assim, as inovações, na maior parte dos casos, elas acontecem ali no dia a dia mesmo, né? Em processos de negócios já existentes e tudo. Então, é importante que o time de transformação digital tenha essa visão, né? Então, a gente hoje, né, se estrutura em termos de estratégia no Lean Delivery, que tem um foco de inovação que fica mais nos horizontes 1 e 2, e temos o Lean Innovation, que endereça as iniciativas mais experimentais, validações de hipóteses, e que pode chegar até o horizonte 3. Né? De maneira geral, falando especificamente em termos de manutenção preditiva, hoje a gente entende que as iniciativas que a gente vem fazendo hoje, elas ficam muito ali no horizonte 2, tudo, mas nós temos uma iniciativa em particular que a gente entende que já extrapola até um pouco o horizonte 2. Ela não é ligada à manutenção preditiva, mas é uma solução que nós desenvolvemos com o uso de tecnologia blockchain e para a negociação de certificados de energia renovável. É o primeiro produto lançado pela Superintendência de TI através do Departamento de Transformação Digital e que gera receita para a companhia, vem gerando receita para a companhia. É um produto bastante diferenciado e isso só foi possível por conta dessa estratégia que foi definida e que efetivamente nós estamos seguindo à risca. E aí, destacando alguns direcionadores estratégicos, né? O primeiro deles é destreza digital, e aqui a gente fala muito de cultura, né? Questão de cultura mesmo, da gente efetivamente fomentar que o negócio passe a ser mais os seus colaboradores pensem de maneira mais que reside iniciativas de self-service, de data analytics, por exemplo, desenvolvimento dos citizen developers. A gente tem iniciativas nesse sentido, habilitar o corpo funcional da companhia a pensar digital, né, e atuar de forma mais autônoma. Como eu falei anteriormente, né, não cabe mais a transformação digital, ela tem um papel diferente do que a TI tinha no passado, né, muito reativo, né, de receber um pedido, né, chegava um pedido de um sistema e a TI entregava o sistema. Isso mudou. A transformação digital, ela eleva, ela coloca a TI num outro patamar e para que a companhia possa ir para um outro patamar também. Temos a área de Data Analytics, obviamente, né, isso é um direcionador fundamental para a gente, e também fundações digitais, ou seja, aqui é onde efetivamente a gente trabalha com as entregas, né, onde a gente estrutura, onde a gente trabalha com entregas de analytics, entregas de robôs de software, enfim. E tudo isso tem como objetivo tornar Furnas uma companhia digital, mais digital. E aí, como é que a gente se estrutura efetivamente para que isso aconteça, né? Então, no departamento, como é que a gente está organizado, né? A gente está organizado em times temáticos, né? Que tem uma forte rede de colaboração, nós estabelecemos uma forte rede de colaboração e troca de conhecimento. Tá? Então, nós temos um time de inovação que está mais ligado à linha de negócio, são inovações incrementais, são equipes que trabalham mais ligadas ao desenvolvimento de sistemas de informação tradicionais, mas que identificam ali potenciais melhorias nos processos de negócio da empresa. Né? Temos o time de hiperautomação, que foca em entregas usando robôs de software, com o uso de inteligência artificial. Temos o time de analistas de negócios, que é uma atividade fundamental para o entendimento das necessidades, das reais necessidades dos clientes da empresa. Temos um time de Data Analytics, focado realmente não só no BI tradicional, que a gente continua atendendo, mas também na evolução para as análises em ciência de dados. E temos o time de monetização, da qual eu sou o head. Né? Cada time desse tem um head, eu sou o head da monetização, e na monetização é onde a gente tem os projetos que eu vou apresentar aqui. Né? Eles acontecem na monetização, assim como outras iniciativas. E aí, falando um pouquinho das duas iniciativas em tela, a primeira delas a gente chama de Insights, tá? Que é o monitoramento inteligente de ativos de transmissão. É um projeto de pesquisa e desenvolvimento desenvolvido em parceria com a PUC-Rio e a Radix. Nesse projeto, a gente aplica técnicas de inteligência artificial, né, mais especificamente machine learning, para melhorar os planos de manutenção de equipamentos de subestação, tá, como, por exemplo, transformadores. Né? O foco desse projeto ele ficou mais voltado para a transmissão, porque hoje a maior parte dos projetos que Furnas vem desempenhando são projetos ligados ao sistema de transmissão. Né? O sistema de transmissão ele vem crescendo, né? Então muitas vezes você tem projetos de reforço, né? Em subestações, e a gente entende que esse tipo de projeto pode trazer um ganho muito grande para a companhia nesse sentido. Né? E como principais produtos desse projeto, né, que estão previstos para serem desenvolvidos, esse é um projeto de 3 anos, a gente está iniciando o 2º ano de projeto agora. A gente tem como principais produtos, né, um Data Lake, né, com todos os dados de operação e manutenção relacionados ao projeto. Então, a ideia é que a gente construa realmente uma arquitetura de dados de referência para a companhia, né, que implemente esse Data Lake, né, com essa miríade de dados que são necessárias para o desenvolvimento dos modelos. Né. Obviamente que esse Data Lake ele vai ser um produto do projeto que depois pode ser utilizado em outras iniciativas da empresa. Né. Além disso, os modelos preditivos para os equipamentos selecionados para o estudo, né, no primeiro momento a gente está trabalhando com transformadores, mas nada impede que ao longo do projeto a gente amplie isso para outros tipos de equipamentos. E por fim, um sistema de software, né, desenvolvido no modelo de plataforma. Né? E aí eu vou falar um pouquinho mais adiante o porquê disso. Mas a ideia é que a gente tenha uma solução que consiga consumir os dados desse Data Lake, né, executar os modelos preditivos e nos entregar insights para a melhoria dos nossos planos de manutenção. Então, falando um pouco mais em detalhe, né, de cada produto, primeiro, está mais no contexto aí do Big Data, que é a criação desse Data Lake empresarial, né, corporativo, com dados relevantes, e aí principalmente relacionados à parte de operação e manutenção de equipamentos de subestações. Né? Inclusive, o projeto originalmente não se chamava Insights, ele começou com esse nome de Big Data, depois a gente escolheu por votação o codinome Insights, que na verdade é um acrônimo de Energy Insights, né, que é o principal objetivo aí do nosso projeto, né, gerar insights aí para os nossos planos de manutenção. O segundo entregável são os modelos preditivos, né, que vão surgir a partir da aplicação de técnicas de machine learning, usando um modelo de treinamento, né, que são os dados, né, combinados, né, de operação e manutenção. E, por fim, a otimização dos planos de manutenção baseados nos modelos baseados nos resultados desses modelos preditivos. Então, qual é a ideia? Hoje, a gente já tem planos de manutenção, né, acontecendo na companhia, né? Nós temos equipes que atuam na manutenção desses equipamentos, realizam as análises de óleo dos transformadores, por exemplo. Enfim, tem toda uma rotina, tem todo um planejamento. O que a gente quer com esses modelos, com o uso desses modelos preditivos, aperfeiçoar esses planos. Ou seja, por exemplo, minimizar o tempo de desligamento de um equipamento desse para manutenção, né? E isso é fundamental para a companhia. Por quê? Porque toda vez que você desliga um equipamento, mesmo sendo de forma planejada, você tem uma perda de receita para a companhia. Então, melhorar um plano de manutenção, em última análise, significa gerar receita ou diminuir despesa da companhia. Eu vou falar um pouquinho mais sobre isso mais à frente. Aqui destacando alguns aspectos tecnológicos, né? Então, como eu falei, os dados relacionados, né, eles vêm de sistemas, né, que estão em uso hoje na companhia, né? E aí eu destaco dois aqui, o SAP, que possui os dados, principalmente os dados de manutenção, né, dos planos de manutenção, os registros das notas de manutenção, e temos o SAG, que é um sistema com dados dos equipamentos de proteção, né? Ou seja, são dados de equipamentos que protegem, por exemplo, o transformador. Então, assim, os dados de operação do sistema que estão no SAG, combinados com os dados de manutenção do SAP, e eventualmente de outros sistemas que não estão aqui nesse slide, que possibilitam um conjunto de treinamento adequado para o desenvolvimento desses modelos preditivos. É assim que a gente entende que a gente vai conseguir efetivamente conseguir bons resultados a partir da aplicação desses modelos, né? Então, esse bando de dados que a gente está extraindo desses sistemas, eles vão constituir o que a gente chama de data lake, que vão servir de um conjunto de treinamento para o desenvolvimento dos modelos preditivos, tendo como resultado os insights para a melhoria do nosso plano de manutenção. E isso tudo, né, tanto o data lake quanto os modelos e os insights, eles vão ser desenvolvidos, como eu falei, numa solução de software, seguindo um modelo de plataforma como serviço. Tá? E aí, falando um pouquinho, antes de eu passar para a próxima iniciativa, hoje a redução de tempo de parada desses equipamentos faz muita diferença, como eu falei, na questão de receita da empresa, né? Toda vez que a gente precisa desligar um equipamento, seja para uma manutenção planejada ou por uma parada não prevista, nós temos perda de receita em relação à função de transmissão da qual faz parte aquele equipamento, né? Isso gera uma perda bastante significativa, nós estamos falando da ordem de dezenas de milhões de reais por ano, tá? Dependendo do grau da quantidade de falhas e tudo. Então, assim, um esforço desse pode se transformar em receita para a empresa muito rapidamente. E aí, falando um pouquinho da nossa outra iniciativa, nós criamos uma solução, né, que hoje é um protótipo, né, para a detecção de falhas em linhas de transmissão. Esse protótipo ele foi desenvolvido durante um treinamento para 10 colaboradores da companhia, né, um treinamento de inteligência artificial. Esse treinamento ele se encerrou tem pouco tempo, tem menos de um mês. E o nosso objetivo Ao longo desse treinamento, nós construímos uma solução que hoje está como um protótipo, né? E qual é o objetivo dessa solução? Detectar falhas, em situações de falhas em linhas de transmissão, como, por exemplo, cadeias de isoladores com defeito, né, com discos quebrados e tudo, usando técnicas de inteligência artificial, de deep learning, né, como processamento de linguagem natural, visão computacional, né, e ele usa como insumo, né, como dado, vídeos que são gravados de inspeções aéreas feitas com o uso de um helicóptero, né? Vocês viram lá no vídeo institucional, Furnas tem 40 mil quilômetros de linhas de transmissão. Então, assim, a inspeção de forma terrestre desse ativo, ele se torna, assim, a logística é extremamente complexa. Então, a única forma realmente de você melhorar, de você possibilitar uma inspeção em larga escala, é com o uso de um recurso como esse, né? De você fazer realmente uma inspeção aérea, e aí nós temos ciclos anuais de inspeção, que nós geramos cerca de 2,5 terabytes de dados, né? De dados em vídeo por ciclo de inspeção. E aí nós utilizamos esses vídeos, fizemos um pré-processamento desses vídeos para extrair as imagens, os frames de interesse, né, e gerar o nosso conjunto de treinamento para esse modelo de visão computacional. E como é que a gente fez essa extração? A gente utilizou o processamento de linguagem natural a partir dos áudios gravados junto nesses vídeos, né? Quando o helicóptero faz essa inspeção, vai um técnico de Furnas, e o técnico de Furnas vai relatando os problemas que ele vai identificando, né? Então, isso está gravado em áudio. Então, a gente faz uma transcrição e, a partir dessas informações, a gente consegue delimitar o conjunto de imagens do nosso interesse a partir dessa quantidade enorme de vídeos que a gente tem. Não seria possível a gente analisar os vídeos manualmente para fazer essa extração. Então, a gente automatizou esse processo. E aí essas imagens formam um conjunto de treinamento para desenvolvimento do modelo. E agora, graças a uma parceria com a Microsoft, né, através de uma parceira, a gente está pegando esse protótipo que nós desenvolvemos ao longo do curso, né, e estamos escalando isso para uma solução automatizada, utilizando o nosso ambiente em nuvem da Azure, né? Então a gente vai vai colocar essa solução num outro patamar para a gente continuar depois o desenvolvimento, já tendo a capacitação dos nossos colaboradores, né? Como eu falei, isso faz muito sentido, né? Porque a gente consegue trazer o tema de inteligência artificial para dentro da companhia, não só para dentro da TI, né? A gente traz para dentro da companhia e os nossos colaboradores podem entender os benefícios que a inteligência artificial pode trazer. E aí eu vou passar um vídeo rápido aqui, só mostrando um pouquinho do funcionamento desse protótipo. Então ele aqui pega uma foto, uma cadeia de isoladores, e ele detecta uma falha, tem um isolador quebrado aqui, um disco quebrado, não sei se vocês conseguiram ver. Ele vai carregar uma outra imagem agora, e também vai identificar, e aí ele identifica inclusive o grau de confiança nessa detecção, né, para cada elemento detectado. Ele vai carregar mais uma imagem agora. E aí não só cadeias de isoladores, mas ele identificou, por exemplo, um ninho de ave. Nós treinamos o modelo para identificar alguns tipos de elemento, não só cadeia de isoladores, mas esferas sinalizadores, ninhos de aves, tudo que eventualmente pode gerar algum tipo de problema, e com isso o desligamento de uma linha de transmissão, que em última análise também gera uma perda de receita para a companhia. Pessoal, era isso que eu tinha para dizer. Deixo aqui meus contatos e estou aberto agora a perguntas aí para a gente dar continuidade ao evento.
Bacana, Marcelo, muito bom aí a gente poder ver, né, a tua apresentação e ver na prática como é que a gente está conseguindo aplicar a questão da ciência de dados, o data-driven dentro disso, né? Eu vou trazer aqui, né, a gente já está um pouquinho, né, caminhando aí com relação ao horário. A ideia aqui, eu vou trazer agora aqui, I'm going to bring Henk and Murad for our to participate of our little debate now. And thank you very much, Murad and Henk, for being here of all of our webinar. Obrigado aí, Murad e Henk, por estarem aqui com a gente. E, na verdade, a pergunta, né, que eu gostaria, né, se fosse possível para vocês responderem e depois darem as considerações finais. So, I would like to introduce the question for our discussion, brief discussion. And after that, if you can complete with your final thoughts about the subject. Então, a pergunta, né, que eu gostaria de trazer é uma pergunta que eu acho que fala muito aí com o que a gente viu nas 3 apresentações, né? No caso, quais, né? Aí, primeiro, né, quais as maiores dificuldades que vocês veem para implementar, né, essa cultura de dados, né, principalmente, aí não só cultura de dados, né, aplicadas, obviamente, à manutenção, mas também em outras, né, aplicações. Então, esse é o primeiro ponto. E como é que você faria isso, né? Como é que vocês têm feito aí para posicionar as empresas quanto a essa importância, né, e a necessidade dessa cultura de dados? So, the question is, what are the most difficult to implement the data-driven culture and the predictive maintenance? So, when we talk about companies, what is the most difficulties that you are seeing? And another questions, how can we implement this kind of culture in practice? It's like doing the job. How can we do that? And after that, after responding, answering the questions, if you can share the thoughts about the seminar and the final speech of all of you, okay? Eu vou iniciar aqui com o Marcelo e finalizar com Henk. So I'm going to initiate with Marcelo, and the last one will be Henk to talk. So, Marcelo, fica à vontade aí para trazer como é que você vê aí quais as dificuldades, né, de data-driven que vocês têm enfrentado aí em Furnas e como é que vocês têm superado isso, né?
Legal, Mandarino, obrigado aí pela pergunta. Bom, a realidade de Furnas não é muito diferente de outras companhias, né? A gente ainda tem dados em silos, né? E isso é natural, né? Esse foi um processo natural, né? Assim, os dados ficarem muito no domínio, né, departamental e não havia no passado uma visão de que esses dados poderiam trazer um maior valor para a companhia se vistos de uma maneira corporativa mais integrada, né? Então, o trabalho assim, as iniciativas elas têm que passar muito pela mudança cultural. Assim, sem isso é muito difícil você evoluir com qualquer outra iniciativa. O desafio não é tão técnico, ele é mais cultural mesmo, né? Então, assim, é você efetivamente mostrar o quanto de valor você pode agregar quando você combina, né, quando você é capaz de combinar esses dados com o potencial que você tem hoje tecnológico para extrair informação a partir desses dados combinados, né, e não só visões em silos de dados, né. Então, assim, hoje a gente tem algumas iniciativas em curso lá, tocadas pelo Departamento de Transformação Digital. Uma delas eu até citei aqui na apresentação, que é o desenvolvimento do Citizen Developer, né? O Citizen Developer é aquele cara que vai ser habilitado a desenvolver lá na ponta, né? E quando ele ganha essa autonomia, naturalmente ele começa a perceber quanto de valor ele pode ter se ele deixar de trabalhar apenas olhando para aquele conjunto de dados que faz parte ali da realidade dele, e o quanto que ele pode agregar se ele estabelecer uma integração, de repente até com um colega do lado, né? isso, assim, é um trabalho cultural realmente, né? Eu acho que as iniciativas elas têm que focar aspectos culturais num primeiro momento. Um outro tema que não pode ficar de fora, tá? O desenvolvimento de uma cultura, tornar uma companhia data-driven é a questão da governança de dados. Isso é fundamental. Assim, quanto antes a gente consegue implementar isso, mais organizado a gente caminha nesse sentido, porque na medida em que você começa a propor de estabelecer uma visão mais corporativa desses silos de dados, você precisa ter processos, você precisa ter perfis, responsabilidades, uma série de coisas, de definições para que isso aconteça como se espera dentro de uma companhia, como, por exemplo, o porte de Furnas, né? Então, não dá para prescindir mão disso. É um trabalho de estrutura mesmo, né? É aquele trabalho que ninguém vê, mas que não dá para prescindir dele, tá? Então, assim, eu destacaria esses 2 pontos, né? E, obviamente, assim, falando questões mais de tecnologias, né? A utilização de ferramentas de análise, né? Plataformas de analytics e tudo, isso é fundamental para fazer essa coisa funcionar e chegar até o resultado, né?
Perfeito, Marcelo, legal. Murad, feel free to answer the question. In your opinion, what would be this most difficulties that you're facing when you talk about with the big clients and big companies in the energy sector? What will be this most challenges like to implement the data-driven and predictive maintenance?
Yeah, well, just like what Marcelo told you, the structure of the database is of major importance, and almost every project that we start, we look into it if the data is structured correctly and is not based on many other databases or what we desire is to have actually a data lake like Marcelo showed. And to that data lake, we connect our software through an API or something like that and collect this data. So this structure is something that we're really missing here. Maybe I don't know if Henk can show his experience based on a global level, but here in Brazil we experience these difficulties. And also regarding when you try to look at this data, it needs to have statistical repeatability. So there's another key point. The data that you insert needs to be representing something. As we always said in artificial intelligence, trash in equals trash out. So if you use wrong data to train an algorithm, the algorithm won't perform well, even if you do the best artificial intelligence algorithm as possible. Another thing that we are also experiencing here, and this is basically what we have discussed with the young pipeline professionals here in Brazil, it's another entity here, is that about the future professional, for future worker on the pipeline industry. And what we already know is that for a artificial project to be successful, we need to have 3 major entities, which is the statistical, the person who do the statistics, the person who develops the algorithm, and the person who knows the business. And the integration of this, it can be multiple people, or at least 1 people, or 2 other people, for example. And to a machine learning project to have to be successful, we need to have the integration of both of these 3 entities, and each entity speaks a different language, and that's also another major difficulty that we have here in Brazil. But especially if talking about the business intelligence, the person who knows the business, he needs to start looking at the the operation that he has, and try to think forward in time, and to try to understand the critical points of the critical data source points that we can collect data and extract value to them, to the company. To have this structured database for future projects. So I said that these are the most difficulties to implement this machine learning and data-driven culture here in Brazil, at least.
Excellent, Murad. And for you, Henk, what do you think? Give us your thoughts about this kind of question. It's like, what, in your opinion, the most difficult to implement data-driven and predictive maintenance on companies in your expertise level?
What I have experienced very often is that the IT department says we just need big data and we do everything. So what you then try to do is to say, I can solve all your problems, but they don't show any results. So if you can't present results, then you're in a bad situation. That's why I made a distinction between engineering intelligence and artificial intelligence. With the engineering intelligence, you use the experience in the market over 30, 40 years, which has been gained, so you can show the results. And the only thing you need to do is a risk assessment. With the risk assessment, you define what is needed. And that means that you need to talk to the IT people, because of course there are IT problems. You need to have an integration of data from the different systems. But you need also to talk to the maintenance people. And the maintenance people, they form actually the crucial part in the whole story. But also the operation people, because the operation people, they hate maintenance, because it takes the machines out of production. So you need to have a good connection between maintenance, operation, and IT. And if that's done, and you start with the engineering intelligence, then the added artificial intelligence will help you in identifying new cases. And that's what I suggest is the best solution.
Very interesting. Normally we think about that, and we see that it's pretty important that C-level buys this kind of thing too. And for me, I think it's the key point that you told Henk, that's the results. Normally when the results comes, and when we can show that the result, the reduction of cost, the increasing of productivity, normally this kind of thing show for the C-level, for the CEO, the importance of doing that and applying that. So that's I normally think that we're having to do using, of course, a process, using approach that it's already seeing that it's a good solution, a good way. Feel free to talk briefly about your final thoughts, and I'm going to start with Henk, and after that, and then finally with Murad. Okay, Henk, feel free to talk a little bit more about the final thoughts that you have about the subject, and if you want to give for us like a message, feel free to do that.
The message is very simple. Think what you can measure and identify. Define what data has what results and which faults can be identified. With that, you need to define a monitoring strategy that will identify your risks. It's not magic, it's very pragmatic. And then show results, document the finances, the finance advantages what you have. Then you will have a business case. So always the maintenance should make a business case about what they do, and then they can be converted into a profit center.
Excellent, Henk. Better than I imagine. Marcelo, pode à vontade aí para dar tuas considerações finais.
Obrigado, Mandarino. Queria agradecer novamente aí a participação, foi ótimo. Foi minha primeira live, né? Já tinha conversado com vocês, fico muito feliz aqui. Tô lendo aqui os comentários aí da Ana Cláudia, sempre prestigiando aí A Cláudia é gerente do departamento, eu sou o substituto, a gente toca junto aí essas iniciativas todas, e muito legal aí os comentários dela. E, sim, acho que muita coisa importante foi colocada aqui relativa a essa parte de manutenção preditiva, né? Como é que tecnologia pode apoiar nesse sentido, né? Achei muito legal assim a colocação do Henk aí no final. Realmente a gente precisa ter um envolvimento do negócio junto com o TI, não adianta isso, assim, essas duas iniciativas que eu abordei aqui na minha apresentação, elas têm envolvimento direto de pessoas de outras áreas de negócio. Elas são as detentoras do conhecimento ali do negócio, da inteligência, da engenharia, né, como o Henk destacou, e é importante esse trabalho em conjunto, sabe? E aí, de novo, eu volto a essa questão da cultura, né? A gente precisa muito exercitar esse entendimento, né, do quanto é importante esse trabalho em conjunto, né? Cada um desempenhando o seu papel da sua melhor forma, mas o resultado só vai sair com todo mundo trabalhando junto, isso não tem a menor dúvida. E, mais uma vez, obrigado aí à audiência, agradeço demais aí a participação e espero poder participar em outras oportunidades.
Com certeza, já está aí escalado, né, Luísa? Já para próximas aí, né, com certeza. Murad, feel free to give us your thoughts and final comments for the webinar, and thank you very much for your participation again and be here as resident in Energy Hub.
Yeah, no, okay. Well, thank you, Energy Hub, for always these good partnerships and the excellent discussions that we have here in these webinars, especially, right? I would like also to thank my webinar colleagues here, Henk and Marcelo. Marcelo, well, this is the first webinars that we have done, but I think that we will have a lot more other topics and other opportunities to discuss about this data-driven. Henk also, okay, and I think that the final message here is that first the integration between the teams, right, the maintenance team, the TI teams is and the operations teams is of key importance to have a successful data-driven project in place, right? And from us, from MindSIM, what we always believed here is in creativity. And that one of our key messages here is, we need to use the software to accomplish repetitive tasks, and to actually so that the people that major governs the company can use their time to actually improve some operation or optimize some process and focus on the operation itself, not on the repetitive tasks that the operation produces. So this is our main belief here in MindSIM, our main culture here, to try to create this AI-driven software to make your time valuable to the company, not to only keep the engine running, but actually to improve the engine. So that's, I think, that's the final message that we have here.
Excellent, Murad. Thank you for all. Even for our audience, né, para a nossa audiência aqui, muito obrigado. E foi um prazer poder estar aqui discutindo esse tema, que é um tema bastante interessante, e com certeza nos veremos aí nos próximos webinars. We are seeing you guys in the next webinar. Thank you very much. Luísa, muito obrigado aí, muito bom tê-la aqui, né, mais uma vez aí, participando, e com certeza novas lives aí surgirão aí com novos temas aí palpitantes, né?
Obrigada, gente, pela participação, todos vocês. Foi um prazer trabalhar com vocês e obrigada pela audiência, né? Pelas perguntas, pela interação. So, thank you, Henk, for being here with us. It was great, and we have now an amazing content for everyone who wants to know more about data-driven technologies and want to, put this in their company. So, thank you, guys.
Don't forget to contact us through LinkedIn or through email if you have any doubts regarding any of these topics.
Yeah.
Okay.
The horn indicates that. So You can use that. So the horn is starting to do okay. Feel free and giving us like a really good like in the LinkedIn and here in the YouTube too. So guys, thank you very much. See you in the next webinar. Bye.
Okay, bye.